All right, so we'll come to this class. We'll be looking at limiting reactants and percentage yield. Okay, so when you're looking at percentage yield, it automatically means you are also looking at the actual yield and the theoretical yield. Okay, so I explained these concepts, and then I have eight questions that we have to solve. Okay, so maybe I'll solve about four of them, and then I'll leave four of them for you to solve, or I'll solve five and then I leave three for you guys to try out. Okay, so we have to explain first of all these two concepts, and then we'll take a look at the sample exam questions that come in the exam, in the tests, or in the quizzes. Okay, so we start with the concept of limiting reactants. Okay, so what is a limiting reactant? So a limiting reactant is just a reactant that is going to determine how much product you're going to what to produce. Okay, so for example, if I can give a practical example that we can experience in our day-to-day life, right? So for example, while you're at home, maybe you have this farm here. Okay, this is the farm that you have. And then in this farm, you want to plant maize. Okay, you want to plant maize. So this is my maize here. Okay, so we can say this is a 10 kg of the seeds for the maize, and then you want to plant them in this your farm here or in this your land. Okay, so let's say you are given this 10 kg bag of seeds to plant in this farm, right? Okay, so um the time that you are going to take, okay, the time that you're going to take to finish planting this 10 kg bag of the maize is going to be dependent, okay, on the size of this land. So if this land, we say it's so big such that the 10 kg bag of maize will only end up maybe up to half here. Let me use another car. We'll end up maybe up to half here. You just plant this part and then that 10 kg bag is done. It means um, the time when you finish planting this is dependent on the what? On the amount of seed that you have. Okay, so it means also the product that you are going to obtain from this farm, it will be dependent on the what? On the amount of seed that you actually what? Planted. Okay, so that's an example of the limiting reactant. So in this case, we're going to say the limiting factor here is the amount of seed. If you had enough seed, you would have continued to plant until you finished all this farmland or this land, right? But unfortunately, the amount of seed that you have only lasts up to maybe half of the farm that you have. So that is going to determine the amount of what product that you are going to get when you harvest. Okay, because of a certain amount of what of maize that you had actually planted. Okay, so that's like an example in real life. But when you're talking about chemistry now, okay, for you to find the limiting reactant, you are just going to be looking for that reactant that will have the smallest number of moles. Okay, not the smallest number of mass, not the smallest number of volume, but the smallest number of moles. So this is where most people actually get it wrong. So you always compare the moles. So for example, if I say, okay, this A here reacts with B to produce what? C. Okay, so let's say I have maybe 20 grams, okay, of reactant A, and then I have maybe 5 grams of reactant B. And then they ask me to find the limiting reactant there. Okay, so how do you find the limiting reactant here? You always convert the moles, I mean the mass to the moles, and then you now compare the moles. Okay, so never compare the masses because the masses they can be dying. Okay, they can be dying. Uh, this one here can have a smaller mass, but it can actually be the reactant which is in excess. Okay, this one can have a larger mass, but it can actually be the what? The limiting reactant. So never follow the mass. Always calculate the what? The moles. So let's say the molar mass, okay, for this reactant A, let's say the molar mass there is 50 grams per mole. Okay, this is the molar mass of this guy. And then this one here for B, let's say its molar mass is actually 2 point, okay, let me just say 1, okay, grams per mole. So you see that when I find the moles, okay, so the moles of A will be equals to the mass, which is 20, divided by what? By the molar mass there. So this will just give me a 20 divided by 50. So that will give me 0.4 moles. Okay? And then if I find the moles of B, so here I was supposed to write B, right? So the molar mass of B is 1. So if I find the moles of B, I find that it is 5 grams divided by 1, which will just give me what? 5 moles. Okay, so now from the reaction here, you get what we call as the mole ratio. Okay, so meaning you're just going to get the coefficients of these reactants. So what is the coefficient of this A? So there is no number in front of this A. So I'm going to say the coefficient there is what? 1. And then what is the coefficient of this? There is no number again in front of the B. So I'm just going to say the coefficient is 1. So meaning that, okay, 1 mole of A reacts with 1 mole of what? Of B. Okay, so now if I have 0.4 moles of this reactant A, how many moles of reactant B do I need for a complete reaction to occur? So since the mole ratio is 1 to 1, then that will mean if I have 0.4 moles of A, then I also need to have what? 0.4 moles of what? Of B. So for this guy here to react with the A completely, we only need 0.4 moles. But you can see that we have 5 moles of what? Of B. So meaning B is in excess. Okay, B is in excess. The limiting reactant there will be the what? Will be this guy here, the reactant A. But take a look at the masses. Here it was 20 grams. Here it was 5 grams. So some students are too quick to judge. They'll just say, oh, the A is 20 grams and then the B is 5 grams. So it means the limiting reactant is the B. So you get it wrong like that. Okay, so always find the moles and then you compare the what? The mole ratios to know that, okay, this one here is the one which is in excess. So you always compare the moles. Please, guys, remember, always compare the moles, not the masses. Okay, so in this case, we would say A is the limiting reactant, okay, because B is in excess. Because B, it has 5 moles in this reaction, but the amount of A that is there only requires the 0.4 moles. Okay, so that's the concept of the whole limiting reactant thing. And then now when you talk about the percentage yield, okay, the percentage yield is not hard to understand because it's just the percentage. Okay, so for example, you yourself, okay, when you're at secondary school or even at the university where you are, when you write a test, right? When you write a test, there's a feeling that you have, okay, like, okay, after writing this test, maybe I project myself to get, maybe I'll get 70%, right? I'll get 70%. Okay. And then once you write that test and then the lecturer marks or the teacher marks, okay, you find that you actually got 69%. Okay. So now to find your percentage yield, you're just going to say the actual marks that you got, okay, divided by the marks that you thought you'd initially get and then multiplied by 100. That's the percentage yield. Okay, so we're saying percentage yield here, its formula is just going to be equals to the actual yield. I'll just write AY, actual yield, divided by the theoretical yield, multiplied by what? 100. Okay, so I gave an example of when you write a test. So maybe you projected that, okay, me, after writing this test, I'm projecting that maybe I'll get 90. Okay. And then after the teacher marks, you find that you get 70. So you just divide the actual thing that you got plus whatever you had projected multiplied by 100. That is going to give you what? Your percentage yield. So that's a practical example for you just to understand the concept. But when it comes to reactions now, okay, this actual yield is what was actually produced in the reaction. So it's usually given in the question. So they will tell you that, okay, this question, once it occurred, once it reacted, it produced this amount of reactant. And then this theoretical yield, you will need to calculate it using what? The mole ratios. Okay, what could have been the amount of product produced if this reaction was perfect? Okay, that's what the theoretical yield is. Okay, so the theoretical yield, we're always going to be calculating it using the information that we've been given in the question and the mole ratios. But the actual yield, okay, we are always going to be given. So like after this reaction, such and such amount of this product was actually formed. That's the actual yield. So the actual yield will be given, the theoretical yield will be calculating it. Okay. And then once you have those two, you just put them into this formula, and then you'll be good to go to calculate your what? Your percentage yield. Okay, so as we solve the questions, I'll also try to re-explain the concept so that we can be moving at the same pace. But if you have any questions, please, guys, ask me, okay? Ask me so that I try to explain and so that you can know. All right, so let's look at the first question here. So if you can't see, you can just put your phone in landscape so that the screen is quite big so that you can see properly. Okay, so the first question here, they're saying, hydrogen gas reacts with oxygen gas according to this equation here. Okay, a mixture of 4.04 grams of hydrogen and 32.0 grams of oxygen is allowed to react completely. Okay, at the end of the reaction, 30.5 grams of water is collected. Identify the limiting reactant and then all those questions that are following there. Okay, so here they say identify the limiting reactant. So let's first of all get the information that we have. So the balanced chemical equation, always make sure that your chemical equation is balanced. So here we have 2H2 plus O2 produces, okay, 2H2O. So we can see 4 hydrogens, even here 4 hydrogens, 2 oxygen, 2 oxygen. So the reaction is balanced, okay? So if it's not balanced, make sure you balance it. So the first question here, they're saying identify the limiting reactant. So let's get the information that we've been given here. So we've been given the mass of the hydrogen gas to be 4.04 grams. And then the mass of the oxygen gas has been given as 32 grams. Okay, so that's what we've been given the information there. And then they're saying after the reaction, okay, the actual amount of water that was produced is 30.5 grams of water. So this here will be our actual yield. Okay, so now to identify the limiting reactant, we need to convert these masses for the hydrogen and for the oxygen. We need to convert them into moles, and then we compare them with the mole ratio that we have. So we know that moles of the hydrogen gas will just be equals to, so I'll divide that mass, which is 4.04, okay, grams, divided by the molar mass of hydrogen gas. So hydrogen gas is H2. So meaning the molar mass of hydrogen, I'm multiplying it by 2. So molar mass of hydrogen, you just get it from the periodic table, it's 1.01. So if I multiply it by 2, because I have 2 of them, that will give me 2.02 grams per mole. So this is the molar mass of hydrogen gas. So I'll divide by 2.02 grams per mole. Okay, so meaning that what would be my amount of moles for the hydrogen gas? So the grams and the grams, they cancel, just remain with the mole. So 4.04 divided by 2.02, that will just give me what? Okay, so let me divide. So 4.04 divided by 2.04, that will, 2.02, sorry. 4.04 divided by 2.02. So that will give me 2 exactly. So these are the moles of hydrogen gas, 2. Okay, what about the moles of the oxygen gas? So the mass we've been given there as 32 grams divided by the molar mass of hydrogen gas. So meaning the molar mass of, oxygen. The molar mass of oxygen multiplied by 2. So molar mass of oxygen is 16.02. Then I multiply it by 2 because I have this 2 there. So I'm just going to get what? 32. So that will be 32 grams per mole. So the grams and the grams cancels out. I only remain with the mole. 32 divided by 32, that will simply be 1 mole. Okay, so don't conclude just yet here when you look at the number of moles to say these are the ones that have the lowest, so oxygen is the limiting reactant. No, you have to compare them now with the ratio from the what? from the equation. So the equation here, you can see this equation here. It says that 2 moles of hydrogen gas, okay, react with, what is the coefficient of this guy? So the number which is in front, not the number that is after like those, no, but the number which is in front. So here there's no number, so meaning there's 1. Okay, so that means 2 moles of hydrogen gas react with 1 mole of what? Of what? React with 1 mole of the oxygen gas there. Okay, so here if I have 2 moles of hydrogen gas, it means I'll still have what? 1 mole of hydrogen gas. So this reaction here is actually perfect. Okay, we can use any of the two to calculate the theoretical mass of water because they are perfect. Okay, so the exact moles of this that will react with this are the ones that are present. Okay, so here we are going to say the limiting reactant there, there's no limiting reactant because we have found the exact same thing. Okay, we found the exact same thing. So there we're going to say no limiting reactant. We can actually use any of the two. Okay, so there's no limiting reactant to answer part A. And then part B, they were saying calculate the theoretical mass of water that should be formed. Okay, so if we had found a limiting reactant, then to calculate the amount of water that would be formed, we would use the moles of that limiting reactant. Okay, but here, since we don't have the limiting reactant, it means we can use any of the moles. We can use either the moles of this or the moles of this to calculate the what? The theoretical mass of the water that was formed. Okay, so I'm just going to say I have 2 moles of hydrogen. Okay, giving me 2 moles of water. Okay, so if I have because this is 2 to 2, so I can divide by 2, so it means 1 mole of hydrogen gas actually gives me 1 mole of what? Of 1 mole of water. Okay, so now if I have 2 moles of hydrogen, it means I have 2 moles of water because the ratio here is 1 to 1. So I'm just going to say the moles of the hydrogen gas is actually equal to the moles of the what? Of the water. Okay, so the moles of hydrogen gas, we found it was 2, so that is 2 moles. So it's the same as the moles of the water. Then once I have the moles of the water, I can now calculate the what? The theoretical mass of the water. So how do we do that? Okay, we know that mole is equals to mass over molar mass. So now here I have the mass of the water that was produced. Okay, I mean I have the moles of the mass I have the moles of the water that was produced, and then the molar mass of water, I know I can calculate it from the periodic table. Okay, so I'm just going to make mass here the subject in order to calculate it. So this will be over 1, cross multiply, mass multiplied by 1, I get mass is equals to the number of moles multiplied by the what? Molar mass. Okay, so now what is the molar mass of water? Okay, so the molar mass of water is 18.02 grams per mole. Check with the periodic table, you get the molar mass of oxygen, and then you say plus 2, the molar mass of hydrogen. You're going to get 18.02. So meaning to calculate my mass of the water, let me erase this. I'm just going to say mass, okay, or theoretical mass of the water, which is H2O, is equals to the moles, which I've found it was what? 2 there. So I'll write 2 multiplied by the molar mass, which is what? 18.02. So if I do this, I find 2 multiplied by 18.02. So that will be what? 36.04 grams. So this is the theoretical mass of the water. So you can see that the theoretical mass, we actually calculated it using the molar ratios, right? And then this one here was the actual yield, was already given, or the actual mass. Okay, so to calculate the percentage yield now, we're just going to say, so percentage yield is going to be equals to the actual yield, 30.5, or the actual mass, divided by the theoretical, which is 36.04 grams, and then multiplied by 100. So this here will be my what? My percentage yield. So what do I get? So I have 30.5 divided by 36.04 and then multiplied by 100. So I get 84.6281,909. So just round it off to one decimal place. That would be 84.6%. So that one there is my percentage yield. Okay, that one there is my percentage yield. Okay, that one is my percentage yield. And then the last one there, they were saying, calculate the excess mass of the reactant remaining here. Calculate the excess mass of the reactant remaining. So on A, we said we had no limiting reactant. Okay, we can use any of them. So to answer D, this was A. So to answer D, since we have no limiting reactant, it means there's no no reactant which is in excess. Okay, so calculate the excess mass of calculate the mass of the excess reactant remaining. We are going to say no excess remained. Okay, everything reacted, no excess remained. Okay, so why are we saying this? Because there was no limiting reactant. Okay, but if there was a limiting reactant, then we would be able to calculate the amount of excess product there. All right, so that was question 1. So any questions there on what we've done before we move to another question? Any questions there? Any questions, guys? Okay, so let's move to part 2. So this is part 2 here. So the concept is just the same. It's just that the reactants now are different, the masses are different, but we're doing the same thing. So here they're saying potassium hydroxide reacts with sulfuric acid as shown in this reaction here. Okay, so always check that the reaction is balanced, and that one there is actually balanced. Okay. And then they're saying 7.7 grams of potassium hydroxide reacts with 25 grams of sulfuric acid, and 6.80 grams of potassium sulfate is obtained. Okay, so let's get the data. So the mass, let me use black. So the mass of potassium hydroxide is 7.7 grams. Okay, so this is the mass. And then mass of sulfuric acid has been given as 25 grams. Okay, and then the mass of potassium sulfate produced. Okay, so I'll write it on top. So mass of potassium sulfate produced after the reaction. So this is our actual yield, was 6.8 grams. All right, so the first question is determine the limiting reactant. Okay, so I said you always look at your reaction to make sure that it is balanced. Okay, so you can see I have 2K here on the left, 2K on the right. Okay, how many H do I have, or hydrogens? This 2 multiplied by the hydrogen 2 plus 2 here I have 4. And then even here I have 2 multiplied by 2. So 4 hydrogens on either side. Only oxygen is remaining. Here I have 2 oxygens plus 4 there. I have 6 on the left. And then here I have 4. And then there are 2. Again 6. And then the sulfur, I have 1 here and 1 there. So the reaction is balanced. Okay, but if it's not balanced, make sure you balance it. Okay, so to determine the limiting reactant, let's find the moles of these reactants. Okay, so I'm going to say moles of potassium hydroxide will just be equals to the mass, 7.7 grams, divided by the molar mass of potassium hydroxide. Okay, so what is the molar mass of potassium hydroxide? So you go to your periodic table, you get the molar mass. Okay, so let me just show the periodic table somewhere here. Okay. Okay, so I want the molar mass of potassium hydroxide like this. So meaning I'm adding the mass of potassium here. We said we always round off these molar masses here to 2 decimal places. So this one for potassium will be 39 point. If I round off that 0.983 to 2 decimal places, I'm just going to get 10. Okay, plus the one for oxygen, it's well known, 16.00, plus the one for hydrogen, that's 1.01. So I can add this 39.01 plus 16.00 plus 1.01. So I'm getting my molar mass for potassium hydroxide as 56.02 grams per mole. So also check on your calculator so that we are consistent with whatever we are finding. So here, this is just going to be equals to, the grams and the grams cancel out. So I just have 7.7 divided by 56.02. So that is going to give me 0.137 5 moles. Okay, so I've rounded this to 4 decimal places. So those are the moles that I have. Okay, those are the moles that I have. And then let me find the moles of the sulfuric acid now. So sulfuric acid, it had the mass of 25 divided by, what's the molar mass of sulfuric acid? Okay, so again, you go to the periodic table here, you find the mass. So sulfuric acid has the formula, this guy here. So meaning we have 2 multiplied by the molar mass of hydrogen, which is 1.01, plus the molar mass of sulfur. So sulfur is there. So rounded off to 2 decimal places, that is 32.07, plus the molar mass of oxygen has a 4 multiplied by 16.00. So this will give me, so 2 multiplied by 1.01 plus 32.07 plus 4 multiplied by 16.00. So that will give me 98.01 grams per mole. So that's what I'm going to divide it with here. Okay, so when I do this now on the calculator, 25 divided by 98.09, what I get is 0.2549 moles. Okay, so those are the moles of sulfuric acid, those are the moles of potassium hydroxide. So now to find the limiting reactant, we are going to compare their ratios from the equation. So from this equation, you can see that 2 moles, okay, of potassium hydroxide actually react with 1 mole of hydrochloric, sulfuric acid there. Okay, so what about if I have these amounts? Okay, what if I have 0.1375 moles of potassium hydroxide? How many moles of sulfuric acid am I going to need? So you put the X there and then you cross multiply. So this will be 2x is equals to 1 multiplied by this, that's simply 0.1375. So I'm going to divide by 2, divide this by 2. So x will just be equals to 0.1375 divided by 2. So that gives me 0.06875 moles of the sulfuric acid. So this tells us that 0.135 moles of potassium hydroxide only needs 0.06875 moles of sulfuric acid. Okay, but look at the amount of sulfuric acid moles that we have here. So we have 0.2549 moles of sulfuric acid. But of that 0.2549, we only need this to react with the what? With the potassium hydroxide. So it means which one is which one is in excess here and which one is the limiting reactant? Anyone who can help us with the answer? Which one is the limiting here and which one is in excess? Try, guys. Which one is it?
I think it's sulfuric acid because it has
Sulf
smaller numbers. And
Sulfuric acid is what? Is it the limiting or the one in excess?
Sir. Yeah. It's in excess. It's in excess.
It's in excess, right? Yes.
Yes,
Okay, so
yes.
sulfuric acid is in excess because the initial moles that we have in the reaction is 0.2549. Okay, but what this other guy needs, okay, the initial moles for the other guy, which is potassium hydroxide, only needs this amount of sulfuric acid. But in the solution, we actually have this amount of sulfuric acid. So it means the sulfuric acid there is actually what? In excess. Okay, so the limiting reactant there is just going to be the what? The potassium hydroxide. Because the sulfuric acid, it is in excess. Okay, so we're going to say the limiting reactant is actually the potassium hydroxide there. Okay, and then the one which is in excess, because sometimes they'll ask you which one is in excess. The one which is in excess the uh, will be the sulfuric acid there. Okay, so we found that. And then now B, they're saying calculate the theoretical yield of potassium sulfate. So if you are calculating the theoretical yield of something, okay, you always get the ratio of that something to the limiting reactant. Okay, on the previous question there was no limiting reactant, so we could use any, okay? But here, because there's a limiting reactant, which is potassium hydroxide, it's the one that we're going to use, okay, in order to calculate the theoretical yield of the potassium sulfate. So let me erase this guy here. Okay, so from the balanced chemical equation, it is 2 moles of potassium hydroxide, okay? It is going to 1 more of the what? The potassium sulfate. So 1 more of potassium sulfate. Okay, so meaning that if I have 0.1375 moles of this potassium hydroxide, how many moles of this potassium sulfate is going to be produced? So X cross multiply, this will just mean that my X will simply be this same guy because it will be 2X, and then on the other side this, and then we divide by 2 to still be 0.06875 moles of potassium what? Sulfate. Okay, so these are the amount, this is the amount of potassium sulfate that was what? Produced. Okay, so the amount of potassium sulfate that was produced. So to calculate its theoretical yield, we're just finding the mass. Okay, so we're going to say mass of the potassium sulfate here is going to be equals to the moles multiplied by the molar mass of the potassium what? Sulfate. Okay, so what is the molar mass of the potassium sulfate? Okay, so you go to your periodic table if you don't know it, then you just calculate it easily. Okay, so potassium sulfate, it's like this. So meaning 2 for the potassium, so 2 multiplied by, the potassium here is 39.10 plus, the sulfur is there, 2 decimal places, that is 32.07 plus 4, and then for the oxygen is 16.00. So if you punch all this onto the calculator, what is the molar mass? So 2 multiplied by 3.10 plus 32.07 plus 4 multiplied by 16. So that will just be 174.27 grams per mole. So this is the molar mass here of the potassium sulfate. So I'm just going to multiply by it here. So that will be 174.27. So if I multiply this, what will be my mass? Okay, so let's multiply 0.08675 multiplied by that mass. It means my theoretical yield that I'm finding here is 11.98 grams. Okay, so that is my theoretical yield of potassium sulfate, okay, or my theoretical what? Mass. And then from there, we calculate the percentage yield of this potassium sulfate. It will be the same thing, just using the formula. So percentage yield is just going to be equals to the actual yield that was produced in the reaction, which was the 6.8, I mean, then divided by the theoretical, which is 11.98 multiplied by 100. So here I'm just going to get, so 6.8 divided by 11.98. Okay, then multiplied by where are the numbers? So we said we are saying 6.8 divided by 11.98 and then multiplied by 100. So that will give me 56.8%. Okay, so that's the theoretical yield there. Okay, that's the theoretical yield. Okay, so any questions up to that point, guys? Any questions there? Okay, so if there are no questions, we'll move on to the next one. So the next one, which is part D, they're saying calculate the excess. Okay, calculate uh, the excess reactant remaining after the reaction. So we said the guy who was in excess, okay, is actually the sulfuric acid, right? So the moles of sulfuric acid initially, they were what? Remember, we found it was 2 point what? Esh, I've forgotten, eh? Okay, so it was 2 point, I can find it anyway. So that's just 25 divided by uh, the molar mass of sulfuric acid, which was 98.09. Okay, so we had found the initial moles of this were 0.254 9 somewhere there. These were the initial modes. And then we said the ones that reacted were only this. So to find the excess modes that reacted, the excess modes that remained, okay, for this sulfuric acid, we're just going to say the modes that were there initially minus the ones that reacted. Okay, so when I subtract this, what do I get? So 0.2549 minus 0.06 875. So the moles that remained for the sulfuric acid are 0.18615 moles. So these were the moles that were in excess. So for me now to find the mass of the excess reactant, okay, remember moles is equals to mass over molar mass. So if I make mass the subject, it will be mass is equals to moles multiplied by the molar mass. So this will just be equals to the moles, it's 0.18615 multiplied by the molar mass, okay, is simply 98.09. So we can multiply this by 98.09. So I get my excess mass. Okay, I get my excess mass to be 18.26 grams. So I've just rounded this off to 2 decimal places. So that is my excess mass of the what? Of the sulfuric acid. Okay, so any questions there on how we've gone about this question? All right, so let's look at another question. Okay, again, it's the same concept, just different numbers and different elements. Okay, so this one is very simple because we've gone through 2 similar questions. So here they're saying hydrogen gas reacts with chlorine gas to form hydrogen chloride. Okay, and they have given us this reaction here, which is clearly a balanced chemical equation. So now they're saying a reaction vessel contains 7.5 moles of hydrogen and 9.00 moles of chlorine. After the reaction, 14.0 moles of hydrogen chloride is produced. Identify the limiting reactant. Okay, so here it's very simple because we've already been given the moles. So we don't have to find them. So just get the mole ratio from here. So the mole ratio from the chemical equation there is that 1 mole, okay, 1 mole of H of hydrogen gas, okay, reacts with 1 mole of what? Chlorine gas, like that. So now here, if I have 7.5 moles of this hydrogen gas here, okay? If I have 7.5 moles of this hydrogen gas there, okay? How many moles of chlorine gas do I need? So the mole ratio is 1 to 1, okay? So it means if I put X here and I do cross multiplication, my X is just going to be what? 7.5 moles of chlorine gas. Okay, because the mole ratio from the reaction there is 1 to 1. So meaning that 7.5 moles of hydrogen gas actually need 7.5 moles of what? Chlorine gas. So which one is the limiting reactant? So here we've been given 7.5 and 9.00 moles of chlorine. Okay, so it means the chlorine there is in what? Excess, because we've been given 9, but this 7.5 of the hydrogen only needs 7.5. So the limiting reactant there will just be what? The hydrogen. Okay, so the hydrogen gas there is the limiting reactant because this chlorine is in excess. Okay, it is 9 moles, but we only need 7.5. Okay, so B, calculate the theoretical amount of hydrogen chloride formed. So he said the theoretical is always calculated based on the ratio with the what? The limiting reactant. So from this equation, I get the ratio from the limiting reactant to my product. So that ratio is 1 mole of hydrogen gas is actually equal to 2 moles of what? Hydrogen chloride, like that. Okay, so this would mean that if I have 7.5 moles now of this hydrogen gas, okay, how many moles of hydrogen chloride am I going to have? So cross multiply, it will be X is equals to 2 multiplied by 7.5. Okay, 2 multiplied by 7.5, it means I'll require 15 moles of the hydrogen chloride. Okay, or simply meaning that from the 7.5 moles of hydrogen gas, I produce 15 moles of what? Of the hydrochloric, of the hydrogen chloride there. Okay. All right, so now to calculate the theoretical yield, I'm just going to use mass is equals to the moles multiplied by the molar mass. So the moles is 15 multiplied by the molar mass. Okay, so what is the molar mass of weight? So here we're not even given the mass, right? We're not given the mass. So we can just do our calculations in just the moles. Okay, so these here are the theoretical moles that are needed. Okay, these are the theoretical moles that are needed. Because here we've been told that 14 moles of hydrogen chloride is produced. So this is theoretical. This is what? Actual. Okay, so we don't even need to calculate the mass. All right, so meaning that here the theoretical amount is 15 moles. So to calculate now C, which is the percentage yield, it's going to be equals to the actual yield, which is 14, divided by the theoretical 15 multiplied by 100. So this is going to give me 93.3%. So this one there is the percentage yield. Okay. And then D, calculate the amount of excess reactant remaining. Okay. So D, to calculate the excess amount of moles remaining, we're going to say the moles that were initially, okay, that were initially in the reaction, okay, because remember the one which was on excess is the chlorine. So the moles that were initially there were 9.00 minus the ones that reacted, which is what? 7.5. So this is just going to give me 1.50 moles of chlorine gas there. The ones that were in what? In excess. So this is the amount of chlorine gas that was in excess. They ask you to find the mass, then you just multiply that moles by the molar mass of the chlorine gas. Okay, but here we just leave it in moles because we are dealing with moles. Okay, everything is in moles. All right, so any questions there, guys? Okay, so let's look at the next question, and then I'll leave the others for your practice. Okay, so let's look at question number 4. So question number 4, sulfur dioxide oxidation. Okay, so here they're saying sulfur dioxide reacts with oxygen to form sulfur trioxide. And the reaction has been given there, which is already balanced. Okay, so now if 96 grams of sulfur dioxide react with 32 grams of oxygen, okay, and 112 grams of sulfur trioxide is obtained, determine the limiting reactant. Okay, so here the mass of sulfur dioxide, we are given 96 grams. Okay, so this is mass, not moles. And then the mass of the oxygen has been given as 32 grams. Okay, so what is the determine the limiting reactant there? Okay, determine the limiting reactant. So we need to find first of all the moles. Okay, we need to find the moles there. So what are the moles? What are the moles of the sulfur dioxide? And again, what are the moles of oxygen? Okay, so let's do that. So I'm going to say moles of sulfur dioxide is equals to the mass, which is 96 grams, divided by the molar mass of this sulfur dioxide. So now remember from the periodic table, the molar mass of sulfur is 32, it was 32 point what? I've forgotten. So 32.07. Okay, so 32.07 plus 2 multiplied by, okay, plus 2 multiplied by 16.00. That will give me a 64.07 grams per mole. So the grams and the grams go. So I just remain with the 64.07 divided by the 96. Oh, it's 96 divided by, not the other way, 96 divided by 64.07. So that will give me 1.498361167. Okay, so you can actually just round this off to 4 decimal places. So it will be 4984. So these are the moles of sulfur dioxide. What about the moles of the oxygen? So the moles of the oxygen, the mass has been given as 32. Again, its molar mass is simply 32. So this is just going to be 1 more. Okay, and then now you compare with the ratio from the equation, this one here. So there the equation says 2 moles of sulfur dioxide react with 1 mole of what? Oxygen. So now if I have 1.4984 moles of sulfur dioxide, how many moles of oxygen am I going to need? So you cross multiply there. So it will just be 2x is equals to 1.4984 divided by 2 divided by 2x is equals to, so I divide 1.4984 divided by 2, that would be 0.7492 moles. Okay, simply telling us that 1.4984 moles of sulfur dioxide only needs this amount of moles for what? For oxygen. But we have one mole of oxygen there. So meaning that the oxygen is actually what? In excess. So the limiting reactant there will be the sulfur dioxide. Okay, and then the one which is in excess will be the oxygen. Okay. All right, so found that, and then calculate the theoretical yield of the sulfur trioxide. So we are getting the ratio from the limiting reactant to the sulfur trioxide. So the limiting reactant is this guy to the sulfur trioxide there. So you see that the ratio there is actually 2 to 2. Okay, the ratio there is actually 2 to 2 from the sulfur dioxide. You can see I have a 2 in front. So the ratio is 2 to 2. So meaning the moles are the same. So meaning the moles of sulfur dioxide are actually equal to the moles of sulfur trioxide. Okay, so what were the moles of sulfur dioxide? They're just this. So that would be 1.4984 moles. Okay, so those are the moles of sulfur trioxide. Okay, so now to find its mass. I'm just going to multiply its molar mass with the moles. So mass of sulfur trioxide will be equals to the moles 1.4984 multiplied by the molar mass of sulfur trioxide, which will just be 32.07 plus 3 multiplied by 16. So that will be 80.07. So if I multiply this, okay, 1.4984 multiplied by that 80.07, I get 119.976888 grams. So this is the mass of sulfur trioxide that I get. Okay, I can just round it off to the nearest whole number, because this one here is to the nearest whole number. So what I get will just be 120.0 grams. So meaning that the percentage yield will be equals to the actual yield that we're given in the question divided by the theoretical yield multiplied by 100. Okay, so I get my percentage yield to be 93.3%. Okay, so that's how we can solve that one. And then the last one, which is D, they're saying calculate the mass of excess reactant remaining. Calculate the mass of excess reactant remaining. Okay, so excess reactant was the oxygen. So excess oxygen will be equals to, so the initial number of moles that I had in the reaction were 1 minus the ones that reacted, which were these. So 0.7492. So 1 minus 0.7492. That will just give me 0.2508 moles. So these were the excess moles of oxygen. And then now I can find the mass. Okay, so the mass of these excess moles will just be equals to the same moles multiplied by the molar mass of oxygen, which is 32. So multiplied by 32, that will give me 8.0256 grams. Okay, so 8.0256 grams was the amount of oxygen that was in what? In excess. All right, so any questions there, guys? Any questions there? Okay, so if there are no questions, this was the lesson for today. I hope you've learned how to calculate the percentage yield and how actually to find the limiting reactant, as well as how to find the excess reactant. So I've put other questions here. So I'll send them in the group, but if you want, you can screenshot. So there's this question here. So try it out. Okay, try it out, and then you can send the solutions to my inbox. I'll be able to guide you. There's also this one here. You can try it out at your own time. There's this one here, you can try it out, and there's also this one here. So I've put like 4 questions for you guys to try out. So I'll send the questions in the group there. Right, so thank you so much. This was the lesson for today. Have a blessed night. All right, so for those who would like to access more lessons on different types of topics, okay, we have them on our website. So you can just go to Chrome, and then you type in discrete, discretelearning.com, and then you go to that website. So this will be the website here, but let me go in my account. So this was someone else's account. So login. Okay. So if you don't have an account, first create an account, then you'll be able to log in. So when you log in here, this is our website. So you can see mathematics, chemistry, physics, biology. So we have videos on all the topics in all these 4 NS courses. Okay. So for example, in this video, we're doing limiting reactants, percentage yield. So if you open the chemistry folder, you go into general chemistry here, you're going to see that you're going to find topic lessons, summarized notes, tutorial sheets and assignments, past quiz and exam papers, and then there are also lab report samples there. So if you want to learn a topic, you go in this folder, written topic lessons there. Okay, so once you open this topic lessons folder, you can see that the topics are well arranged here. So from introduction to chemistry, units and measurements, accuracy and precision, atoms, molecules, isotopes, the more and stoichiometry, solutions stoichiometry, molarity, all these things are nicely arranged on this website. So you can actually learn at your own time. Okay, so from introduction to chemistry all the way to basics of organic chemistry there. The videos are there, chemical kinetics. Okay, we have videos on all those things on our what? On our website. Okay, so make sure you subscribe, then you'll be able to access all these to use them at your own time, at your own pace, even in your blankets. Okay, and then we also have, apart from that, we also have a folder for the tutorial sheets here. So we have a lot of tutorial sheets that have been solved, and you can access them from there, plus the past quiz tests and exam papers are uploaded in this folder. Okay, so make sure you subscribe. So check the link in the description here. Okay, you're going to find the link to our website. You're going to find the link to our mobile app. So on the mobile app, you can even download the videos and be able to watch them offline. Okay, you can download the videos and watch them offline. And there's also a video registration guide. Okay, but if you want to get in contact with me, you can call me on 0779 96 40 10. Okay, so that is the tutor for solutions. Okay, that is Tutor Pro Solutions. You'll find me on that number. So you can WhatsApp me or you can give me a direct call if you need help. Okay.